So hopefully as you work through these first 6 problems, you noticed a pattern. Maybe not so much on the last 3, but we ended up with x squared minus 4. So down below, you see some questions. What pattern did you notice in A through C? So if I multiply B out, the middle terms always cancel. Okay? And so what is it about these factors that makes that middle term cancel? So the factors are exactly the same. They have the same numbers and variables, except one's plus and one's minus. Whenever that happens, we call them, so this second question down here, they are called conjugates. Now remember that word because we're going to use it later on. Only if you want credit. The second one. So if you have 2 identical factors that have a different sign in the middle, they're called conjugates. The nice thing about conjugates is that middle term always cancels. So if on number C, I don't even need to worry about the middle term. I know it's x squared, and I know it's minus 49, and I'm done. So on part D, I can get 36a squared minus 49. And that middle term, I would have a negative 42a and a positive 42a, and they'd knock each other out. Okay? But letter E is a little bit different. E is not a set of conjugates. But when we multiply it out, we get 18x squared minus 66x minus, or sorry, that one was plus, minus 66x, and yeah, apparently I don't know, minus 242. But the middle term canceled, and I get 18x squared minus 242. If we look at part F, the same thing happens. 12x to the third minus 30x squared plus, oh, wait, that one's, oh, shoot. Change one of those signs. That's my fault. I'm sorry. Minus 30x, oops, that's minus 30x squared. And then 15 and 5 is 90? Nope, 75. Sorry. Minus 75x. And notice the middle term cancels. 12x to the third minus 75x. How come they canceled? They're not conjugates. They're what? They add to 0, but I thought it was only conjugates that created middle terms that canceled. And that's true. Look carefully at this factor. How does that factor compare to the other factor? It's exactly double. So it is a conjugate, but there's a little 2 hidden in there. Is that true of letter F? Right. So what is the common factor in F that I need to bring out? 3x. This first factor has an extra 3 and an extra x. Right, so this one is actually 3x times 2x minus 5. Well, it's actually plus. And then 2x minus 5. So it is a pair of conjugates, but I was sneaky and I multiplied that through. But because we started with a conjugate, that middle term canceling is preserved even when we put in extra information. So on number E, if I pull out a 3, then I get 3x minus 11 and 3x plus 11. Oh, you're right. It's a 2. Thank you. So the third question says, what do we call this type of quadratic? So the ones A through D, they're called, and this one, students forget it, but you need to remember it, difference of squares. So if I take a factor and its conjugate and I multiply them together, the middle term always cancels, and we end up with what is called a difference of squares. Yeah, that's the third one. Okay? So if I look at part D, it's called a difference because the answer is always, the middle number is always negative. And it's called squares because the first term and the second term are perfect squares. X squared, 2 squared, 9 squared, 7 squared. Even this one, 6a squared, 7 squared. So if we go down a little bit, why did the middle terms cancel in problems E and F? Because there was a hidden conjugate in there. I just kind of disguised it a little. So, if I want to factor a difference of squares, it's really easy. Oops, wrong way. So part G. Is part G a difference of squares? Is it something squared minus something squared? Yes. X times x minus 1 times 1. So this factors into x minus 1 and x plus 1. What if it said x squared plus 1? Does that factor? No. Let's try it. My options are x plus 1 and x plus 1, and x minus 1 and x minus 1. Will this have middle terms canceling? No, I would get x squared plus x plus 1. And this one I would get x squared minus x plus 1. What's wrong with those? The middle terms have the same signs. So the only way it works is if one of these is a minus and the other is a plus. But if that's the case, then you would never get a plus 1. It would be a minus 1. We'll get to that. You're getting ahead of me. So, be careful. If you see x squared plus 16 and you say, great, I know how to factor that, it is not a difference of squares. It's the sum of squares. And in fact, the answers are imaginary in that case. So don't fall into that trap. Okay? And think about it. If I set this equal to 0, x squared equals, I subtract, what number times itself is negative 16? There isn't one. It's imaginary. So that doesn't work. Okay, letter H, y minus 12, y plus 12. I is pretty easy. What about J? Is it a difference of squares? What are my factors? 4x, minus 7, and plus 7. Okay, that's not too hard, right? And then we come to K. Is K a difference of squares? No. 3 is not a perfect square, and 54 is not a perfect square. But does it have a difference of squares hidden in there? We can pull out an x. Can we pull out anything else? We can pull out a 3. So if we pull out a 3x, what's left? X squared minus, oh, is it really 18? Oops. I think that's supposed to be a 48. What's 48 over 3? Please tell me it's 16. You guys are the guinea pigs. Sorry. Even if you knew how to do it, it wasn't possible. Okay? Now can I factor that further? Ashton, you might want to pay attention. 3x times x minus 4 and x plus 4. Okay. Is L a difference of squares? Yeah. What are my factors? What times itself is 4a squared? 2a and 2a. So it's plus and minus. 5b and 5b. Does anybody not understand that? Other than the fact that I don't know how to multiply by 3. Okay, letter M. Now, instead of just looking for the factors, we want to know the roots. And remember, the roots are the places where the graph touches the x-axis, or they're also the numbers you plug in to make the equation equal 0. So we start by factoring. This is a difference of squares, so it's x minus and x plus. 5 and 5. So what are my factors? 5 and negative 5. And I'm so lazy, I don't like to write 5 and negative 5. So I write plus or minus 5. Okay? So for letter N, it's going to be x plus or minus 6, which gives me x equals plus or minus 6. Well, technically minus plus 6, but that doesn't change anything. Okay? Letter O is written backwards. What do we do there? Nothing. It doesn't matter what side the equal sign is on. So I have x plus 10, x minus 10. So x equals plus or minus 10. Is letter P a difference of squares? So what times itself is 4x? 2x. So 2x and 2x. And I do have a subtraction. So I can write plus and minus. 5 and 5. Now what are my roots? What number makes this equal 0? Well, that's a little bit hard to think about, so let's just solve it. What is 2x plus 5 equals 0? I'm going to subtract 5, 2x equals negative 5, divide by 2, and I get x is negative 5 halves. (2.5). So on the other one, I set that equal to 0. Going to add 5 and divide by 2, so it's just plus or minus 5 halves. Okay. Is 196 a perfect square? What is it a perfect square of? 14. So this is 2x minus 14 and 2x plus 14. What do you... No, go ahead. I don't... So, oh, are you saying this? Yeah. So add the 14, divide by 2, and I get 7. Subtract the 14, divide by 2, and I get negative 7, so plus or minus 7. Could I have made that easier on myself? How did you do it, Jaron? So that would work. Do these have any common factors? 4. I could have pulled a 4 out and got x squared minus 49. And then this has no bearing on the answer because it doesn't have an x in it. It's a factor, but it does not affect the roots because there's no x's. So we can drop that, and then we just end up with x plus 7 and x minus 7. So even though it was a perfect square, you could have factored out a 4 and got the same answer. But it works either way. All right. Letter R. Is 18 a perfect square? No. So what do? I can take out a 2 and an x. Now this one's a little bit tricky. That leaves me with 9x squared minus 4. Can I factor this quadratic any further? Yes, it's a difference of squares. 2x times 3x plus 2 and 3x minus 2. So my roots are, if I set that equal to 0, add the 2 and divide by 3, so I get plus or minus 2/3 and 0. Because we're going to set every x equal to 0. That one equal to 0, this one equal to 0, and this one equal to 0. Well, what number makes 2x equal to 0? 0. It's the only option. So whenever you pull out an x, you know that the graph hits at 0 every time. Okay? All right, your assignment today is to do the back side of that. I hope there are no mistakes on it. If there are, please let me know. Good luck.